function notation. It shouldn't have been the first time you've seen it. I'm not sure if you've done compositions of functions. So compositions are kind of funny because you're doing multiple function notations in one problem, and you actually work from the inside out. So you want to start inside. So this would be read, and let's make sure we're reading this properly. F of G of 1 is how you would read that. And you work from the inside out, meaning we're going to do the G of 1 first. So if you look up here to the G function, because we're doing G of 1 first, and you plug in 1, you get 2 times 1, which is 2, plus 3, which leaves you to 5. So G of 1 equals 5. So then we do F of 5. Yes? Okay? I didn't really show it, but you want to make sure you know where that 5 came from. How did that 5 replace G of 1? Well, it's because I did G of 1 equals 2 times 1 plus 3. That was like my side mental math. And then with F of 5, we're now plugging 5 into the F function. So that is 5 squared minus 5. 25 minus 5 is 20. That's your answer. Okay? Look down at D. Different notation. It almost looks like the letter O in between. That's not what it is. But this is the same way of writing F of G of negative 2. Means the same thing, it's just written differently. So you're still going to work kind of inside out. F of G of negative 2, you're still going to do G of negative 2 first. And if I go up here and I do G of negative 2, 2 times negative 2 gives me negative 4, plus 3 gives me negative 1. So G of negative 2 equals negative 1. So I'm replacing that G of negative 2 with a negative 1, and now I just have to do F of negative 1, which is negative 1 squared minus 5, which is what, Jack B? Negative 4, good. Okay, I want you to jump to either C or F. I'll go to F because this particular composition is the same function twice. So F of negative 1. So what you'll do still, inside out, is you'll figure out what F of negative 1 is. And if I do that, F of negative 1 is negative 1 squared minus 5. That's negative 4. So now we're doing F of negative 4, because I'm replacing that initial F of negative 1 with its negative 4 value. And F of negative 4, I'm still dealing with the F function. That's going to be negative 4 squared minus 5. 16 minus 5 is 11. And so that would be the answer there. And all of these are just compositions of 2 of them. You could have F of F of F of F of 5. It would take that many layers of work, and the number would keep changing every layer that you go through. But you can compose as many of these as you want. Okay? You probably won't ever see more than 3. Any questions? Okay? The graphs below are of the function y equals f of x. So we're showing you f of x here. It's labeled. And g of x, we're showing you g of x here. So we've got a linear and a quadratic. So again, just like yesterday, we have to do this function notation skill with equations, with graphs, and with tables. Although I don't have any tables on this worksheet. But with A, starting inside out, the first thing we want to look for is what is f of 2. So we're going to go to our f graph. We're going to look when x is 2, y is 3. So that's going to become g of 3, since f of 2 is just 3. And then g of 3, we go to our g graph. If you go to your g graph, an x value of 3 pairs with a y value of 3 as well, so g of 3 equals 3, and that's your answer to part A. Okay, I want you to try B on your own. Alexa, what'd you get? 0. Eric, what'd you get for B? 0.5. So we have a 0. Someone else got a 0.5. Lucas Coletta, what'd you get? 0.5. Anybody get anything different? Go ahead. Negative 0.5. Anybody get anything different? Okay, so everyone got one of those. I don't know what it is because I haven't looked, but we're about to find out. So obviously, there's something to be learned here, which is good. G of negative 1 is where we're going to start. So we're going to go to our G graph. And when you go to an x coordinate of negative 1, the y is negative 1, 2, 3, 4, 5. So G of negative 1 is negative 5. So now I'm just going to do f of negative 5. So if I go to my f graph, negative 5 as my x coordinate, 1, 2, 3, 4, 5, gives me a y coordinate of, it looks like negative a half is correct. Okay? Go ahead and just work through those, and then I'll give you a few minutes and see what we have. All right. Vince, what did you get for C? 3. What did you get for that one, Tess? 3. Did anyone get anything different? Speak up. If you did, it's an opportunity to learn. You're just not saying anything because the first 2 people got 3 and you don't want to. You're not willing to risk your pride to grow as a person and learn, are you? You little ones. Okay, so I'm not going to go over it then. 3 it is. How about D, Mike?
3.
What did you get for D, Bella? 3. Did anyone get anything different? Good, Lucas.
I got 4.
4, so let's look at that one. We got to do f of negative 2 first. Lucas, what did you get for f of negative 2?
2.
There's where your mistake is. Because if you go over 2, it's only 1. Good. So G of 1 And then you go to here, 1 is 1, 2, 3. Good. Thank you, Lucas. E, what did you get? Owen? 2? Jason, what did you get for E? 2 as well. Anyone get anything other than 2? Okay, going with it. And part F. Chris Brooks? 3. And Faye, what'd you get for F? Okay, we got a 3 option, a 2 option. Anyone get anything other than one of those 2? Okay, let's see. So f of 0. So f of 0 over here, when x is 0, the y coordinate is 2. So this is definitely 2, and then we're doing f of 2. Same graph, when the x coordinate is 2, the y coordinate is 3. So that should have been 3. You counted wrong, yeah. All right. Very good. Okay. So on the back, this is a little interesting because it's not asking us for f of g of a number. It's asking us for f of g of x. So given the functions, here a linear, g of x is also just a different linear, determine formulas in simplest y equals ax plus b form for f of g of x. So normally, if that x was a number, we would plug that number into g and see what we get, and then take that answer and plug it into f to see what we get. But because we don't have that number, g of x is just 5x plus 4. That's the best I can do. G of x, the f stays, but g of x is just the equivalent of 5x plus 4, as is stated above. And then once you see it in this fashion, we did do a little bit of this yesterday, where you're not always asked for f of 5, f of a number. You have to be comfortable plugging in polynomials. So f of 5x plus 4 means plug 5x plus 4 into this. So that's 3 times 5x plus 4 minus 2, and simplify, because they want this in y equals ax plus b form. So that's going to be 15x plus 12 minus 2, which is going to simplify to 15x plus 10. And b looks like the same, and we'll learn something from this. Do you think they're going to be the same? And this is worth learning, because if they are always going to be the same, then you wouldn't have to do any extra work. But let's see. So if we do g of f of x, we need to take f of x first, and f of x is 3x minus 2. So we need to do g of 3x minus 2. So that means take 3x minus 2 and plug it into the g equation here. So that will be 5, and then I'm plugging in 3x minus 2 plus 4. And then when I distribute that, I'm going to get 15x minus 10 plus 4, which leaves me with 15x minus 6. So they're not the same. Order definitely does matter. In rare cases, when the two functions have a special relationship that we'll get into later, either order will be the same. But that only happens with two functions that are kind of special to each other in a certain way that we will learn more about. Okay? I want everyone to try exercise 5 on your own. It's a multiple choice, so then we'll take a vote. Okay, so on the count of 3, you're going to hold up either a 1, 2, 3, or 4 based on the option you're choosing. If you have no idea, hold up a fist. On your mark, get set, go. Wow, overwhelmingly I'm seeing 4. Couple, they got something different. So I'm going to say if math by majority wins, 4 is the answer. So let me see, because I haven't looked at it yet. So f of g of x. So we're starting with g of x, which is x minus 5. And we're going to plug that into the f function. So that's just going to be x minus 5 squared. Now, if you try to invent a shortcut, which we kind of already talked about with Angie this morning, and you want to square the x and square the 5, you're probably going to get either 1 or 2, which is incorrect because you can't do that with polynomials. You have to expand and FOIL x squared minus 5x plus 25, which does land us at option 4. Nice job. Okay? Now, 6 and 7, same topic, composition of functions, but given to you in the context of a word problem. Now, I already pulled out some of the variables that I see are an I, an H, and a T. I actually see an I twice, but it's the same I. I is intensity, T is temperature, H is hours past 6 a.m. So I just kind of pulled those out. You don't necessarily need to write that part down, but so let me read it. Scientists modeled the intensity of the sun. That's what the I is. When you see intensity, it's the intensity of the sun as a function of the number of hours since 6 a.m., H. So this is important. If it's 10 a.m., what am I using for H? 4. You have to always pay attention to that carefully. It's not, the number of hours period, so 10 a.m. is 10 hours. It's the number of hours since 6 a.m. So if they ask you about something at 10 a.m., H has to be 4 because it's 4 hours since that 6 a.m. start. So you figure out the intensity of the sun based on how many hours after 6 a.m. So there's what that looks like. The intensity of the sun obviously changes as the day goes on past 6 a.m., correct? Okay. It increases at first and then decreases, hence the reason why we're looking at a parabola or a quadratic. Then they also model the temperature of the soil as a function of the intensity of the sun. So the temperature of the soil is going to change based on the intensity of the sun. Makes sense, right? If the intensity of the sun is greater, the temperature of the soil is probably greater, and so on and so forth. So which of the following is closest to the temperature of the soil at 2 p.m.? Well, we're asked for the temperature of the soil. So we're asked for T. In order to find the temperature of the soil, we need to know the intensity. But did they tell us the intensity at 2 p.m.? No. We need to go back and use the other equation to find the intensity at 2 p.m. so that once we know that intensity, we can use that intensity to find the temperature of the soil at 2 p.m. So here's why this looks like a composition, because you want the temperature as a function of the intensity, but the intensity is a function of the hour. And so what we're going to try to find is the temperature at 2 p.m. So what's the H I'm going to be using? 8 hours. Good. I can't just, the T and the hour are not directly connected. I mean, they are, but we haven't been given that straightforward formula. So we're going to find I of 8 first. And so that's just going to require plugging in 8 into here. So I'll just do that in my calculator. 12 times 8. Whoops. 12 times 8 minus 8 squared will give me that numerator. I'm going to divide that by 36. So there's my 0.8 repeating. So I of 8 is 0.8 repeating. Great. The intensity at 2 p.m. is 0.8 repeating, whatever that means. I don't know what the units are on intensity. And then the temperature at that intensity level, I'm going to use this formula. So that's going to be the square root of 5,000 times that 0.8 repeating. So square root of 5,000 times, and you guys know that rather than copying that down, you can just go up and select, hit enter, and it will draw that down for you. Because you want to use exact decimals. You don't want to round that to 0.9 because you'll get a very different answer. Not very different, but it will be off. So 66.6 repeating. Chloe.
Can you put it as the fraction 8 over 9?
Absolutely. 8 nines. Yep. Because that's what 32/36 would reduce to. Good. Any questions? Okay. This next one is very similar, S of K, and then K of C. So they're going to ask you for the S, the speed, at a Celsius degree of 30, but we don't directly connect S with C. We have S of K and K of C. So there's your composition, and you would need to find S of K of, S of K of 30 degrees Celsius, and it's kind of like a two-tiered problem. We're not going to finish that up, but let's see this stuff. Hey, Eric. You can go see Mrs. Siegel. So you can go ahead right now.